My name is Ernst Vetja. I'm a business development manager at Robit. We are a Newspace satellite provider from Finland. We're bringing a fresh wind of software-centric ideas into the industry, and I will explain more what we do in this short presentation, merging Newspace and the classic space with software-defined satellites. But first, maybe some more words on who I am. I'm from the south of Sweden. I'm an aerospace engineer at heart, and I have been both in the private and the public sector from my career until now, and I've been in the GomSpace, the nanosat provider, and also within the European Space Agency. So yeah, let's dig in a bit more. So first, an overall introduction of the company, I think is good to start. Robit was founded in 2019 on the notions that satellites today are still quite dumb, monolithic, unconnected, expensive systems, much like Sputnik 1 itself was back in '57. And a new solution was needed to open and enable the possibilities that space have for humankind and for our life here on Earth, that could merge the benefits of Newspace and classic space, which we see to be the ideal path forward. We achieved this with an in-house developed software-defined architecture that focuses on connectivity and space and data flow in space, basically, but also space to ground side. Our solutions are focused on the data, which is in the end is the true value of our customers, of the users of space equipment. And our systems ensure efficient, secure, and reliable delivery of that data, no matter what type. This is sort of a new approach we see that we are pursuing. So we're headquartered in Helsinki, in Finland. We have two global branches, one in Stockholm, in Sweden, where I'm located, and one in Bariloche in Argentina. Our main development and manufacturing activities are located in Finland and are planned to be there. We're currently on an expansion of our current facilities, including the labs and the clean room for the manufacturing and the AIVT. To meet the demand we see, and we foresee to open these in a few months. So Robit was founded by Setu Suvanam, who is also our CEO today. He has a background from a PhD background from Rad-Hard Materials for Space. He also worked in ASC Clyde Space in Sweden. I think this slide gives you a quick overview of our management team and the leadership behind Robit as of today. Although we are a younger company, our team is not inexperienced. We have a mix of young professionals and seniors who together creates a very competent environment and pool of skill sets. Ignacio, for example, is our CTO and comes from some ISI, as some of you might have heard about before, quite successful company from Finland. Also, he has experience from INVAP. We have John as an extensive background with entities like ESA and REA, and lastly Astroscape, but also others in Europe. We have Carlos from INVAP, HB, Airbus, Karen as a finance and M&A background from SEB. And the last to mention here is Jean-Jacques Dodin, which is the ex-director of ESA, and he is a strong supporter of our mission and functions as an advisor for us. So this image is what I call the Robit world vision. It visualizes how we unlock data flow in space with our solutions. The world has a need of smarter, more connected systems in space that in the end allows the true integration of space and Earth systems and solutions. By the end of the day, Robit is a a satellite provider, a system integrator based on our in-house developed software core. This core allows us to see satellites as nodes in networks instead of single-use or single-function isolated entities, which is the previous notion of the industry, or still today, sort of the standard. Data can flow or should flow between our systems and also between other systems, of course, by adopting and optimizing for the ongoing standardization of intersatellite links, mainly on the laser, on the optical side. Next gen solutions such as live stream Earth observation, data relay services, HTS, SATCOMs, will be enabled by solutions like us and potentially others. And we offer both this core of a software or an avionics core as a product for manufacturers to integrate, or we put this core in our own platforms and offer a flexible platform solution for missions in the range of 200 to 500 kilos sort of wet mass. The visually more isolated system here in the picture, the small SATCOM, is also a product of our offering, but it's based on the same foundation basically, but built to target specifically the need of secure regional capacity, either as a kind of gap filling system or a dedicated service, defense related. It's also an entry into civil SATCOM solution for nations with lower budgets basically, or operators with lower budgets, as it is a smaller solution. So to the topic of the presentation, why merging Newspace and classic space? We think the space services of the future needs the best of both, to the extent possible, of course. Imagine if computers and phones were still today hardware focused, unconnected, and expensive. The world would be very, very different from what we see today. We can only truly exploit space solutions as we have exploited phones and computers and other systems here, when we connect basically. And we can only bring the true benefit of Earth and humankind if the systems are software defined, connected, with high functionality, high reliability, which we bring from classic space, at a lower cost, which we bring from Newspace. We need a commoditized satellite industry, and we achieve that by our software and avionics core, as this figure here should represent. This is an isolating area or layer. The core isolates between the applications, basically the service providers and the end users on one side. It isolates them from the lower underlying hardware subsystems. It's very much like how operating systems in phones and computer are isolating us as end users or service providers from the underlying systems of those equipment, basically. This is what it allows, and then it's the application and service provider to be more focused downstream. If that system is taken care of and efficient and very flexible, you can focus on bringing the actual value to your solution in a more efficient way. So the value proposition generally we at Robot try to generate is a lower cost for space solutions, higher flexibility, simplicity, while keeping the high performance, reconfigurability as software defined solutions can do, and we have a strong focus on bringing autonomy in orbit, basically relaxing the operators, so to speak. and so on. So as recent as a few days ago, actually, now during the Satellite 2023 conference, we partnered with AAC Clydespace to commercialize one of these products, this avionics core. We call it the Muon product, or the Muon avionics bundle. It's a standalone flight computer system, a game changer, we think, for the industry, as it relaxes the need for in-house development of complex flight softwares, and simplifies the system integration on the other side. It's built for reconfigurability, adaptability in space. So your mission it's not single function and not predefined, but you can actually evolve your mission. Of course, your hardware that you fly is there, but from a software perspective, you can evolve your mission over time. It's a one-of-a-kind, state-of-the-art, soon-to-be flight-proven system, both for you as an integrator, but also it's the foundational brick in our own solution, which I will come to here in the next slide. So what we do is to take the Muon and bring it into our platform designs. So with Muon at the core, we provide a highly flexible bus we call the Gluon. This is a software-defined platform complementing software-defined payloads, as you see ongoing in the industry. It's optimized for, again, connectivity, again, autonomous operations. It is default equipped with the optical or laser communication terminals, both for the space-to-space links between our systems, but hopefully between others if the industry embraces a standard such as the SDA. But we also look at the space-to-ground links to have a complete route of fiber in the sky kind of solution. It's also designed, or why we present the kind of range of mass is because we adopt, or today we adopt to the rideshare ready, or the rideshare solutions for launch, which gives you quite efficient price point, also from the launch side, not only from the platform side. So we say it's scalable or suitable for a 200 to 500 kilos service in LEO or MEO. And today we have commercial contracts for both, for this platform, for both for LEO and MEO missions. Our small SATCOM, is a little bigger product and more dedicated to GEO. However, on the comms side, we are still enabling other types of low latency services. Yes, we have already touched a bit upon the topic of what type of applications we enable, but our software-defined approach is designed to supply the demand of connectivity and digitization we see worldwide, basically in every society, every nation, everywhere. We still have a gap to fill on the data capacity. We build for any type of service because we have this approach. We are not locked to one type of mission or one type of underlying hardware. The supply chain management becomes a critical part for us, but from our side, we are bringing that live. We think the market is ready to be commoditized. So a system integrator approach is here. We look at Earth observation, data relay, SATCOM, on-orbit services such as life extension missions or rendezvous docking, debris removal services on the commercial side. On the governmental side, we are mainly focused on secure dedicated comm solutions, potentially defense related, as well as surveillance missions. And today, as I said, we have already some partners looking into both LEO and MEO services. we're also in development with ESA and the European Space Commission for mainly the software part of what we do, but also on mission side. So this was a short overview of what we do and how we try to enable the best of both these worlds, and how we do that from a software perspective, in a way, and how our solutions hopefully can be a game changer and truly open the potential for those future businesses or services that we need here on Earth. I think we are ever more dependent on space. Some of us even don't know how much we use space, but I think that's just the start of the journey. So yeah, thank you for having me here, and thank you for listening in. And I'm happy to receive questions or get connected in outside this forum as well.
Perfect. Well, thank you for the presentation, Ernst. Thank you for the energy, for the insightful presentation. And obviously, we do have a few questions from the Q&A, and I have questions from my side as well. So first of all is coming from Subham. So he's asking, what size satellites do you currently work with?
What size?
Yeah.
So our current contracts are in the range of 200 to 400 kilos, spanning over the contracts we have. Commercial side, we are ourselves involved in a demonstration mission with ESA. That is a smaller spacecraft. So I would say, depending on the origin of the question, we can do many types of sizes, but today we are working actively in mass then on 100 to 400 kilos. However, our designs and architecture is, I mean, since we are basing everything on a software-defined avionics core, it's basically mass independent. The spacecraft fully depends on what subsystem we connect to it. Like how you design a computer, you have your operating system and the core components, but if you put it in a bigger structure or add, bigger batteries, it gets more powerful. It's the same for us. So we have a suitable range where we see a low cost and high performance ratio of those couple of 100 kilos, basically.
Thank you, Ernst. Second question we have coming through Gavin. So he just wants to make sure if he heard right, which you said that the satellites would perform optical inter-satellite communications using lasers, and he's asking, would these lasers need a pointing and tracking system to send data to the right satellite, and how difficult is to achieve that?
That is has been a challenge. I think now those systems are becoming quite mature. So we are not ourselves developing that capability, but instead we are partnering with the state of the art of the industry. There are a couple of players worldwide that can provide these laser communication terminals for ground segment, but also for the actual flight, the satellite systems. So we build for those, and we build a solution where we can have different suppliers plugged in. So the pointing accuracy becomes a question for us, yes, on the platform side, but within many of those equipments, the LCTs themselves, they have a gimbal and have an automated function to detect, to search for signals, detect and lock, and adjust to that. But we, on the platform side, we also fulfill the requirements we need. So I think the two answers there: the platform and the equipment itself, which we are not developing, together creates the capability to lock over great distances, basically.
Okay, thank you for that. And the last question I also have here from our side. So how do the software defined satellites enable Newspace applications and services? So such as dynamic mission reconfiguration, adaptive communication protocols, and real-time data processing and analytics.
Yeah, exactly. I think we build basically an operating system allowing for applications or those more exotic, complex, newer applications to just go on top of our operating system. That we build the foundation where a business can really go focus on that value. For example, on the processing side, or for some other on-orbit services mission. Our solution is very suitable for that because you're isolated from all the underlying stuff. So our platform takes care of the satellite performance, of the maintenance, of the station keeping, of the communications on the TTC side. So you basically get a layer where you can plug in your solutions. I think that's at least for me, the key value to open for those kind of innovative solutions.